Okay, so today I'm talking about the transportation systems management and operations. And I'll start off by just doing like a quick talk about traffic engineering, just for the benefits of anyone that might be online that isn't necessarily involved in traffic engineering. We'll do a little quick talk about the transportation systems management, and then I'll talk about some strategies and examples that I have personally been involved in, and just also what it takes for us to integrate the transportation systems management approach into our projects. Okay, so traffic engineering usually is just the sub-discipline of transportation engineering. I think most of us take some courses about traffic engineering when we're doing our undergrad, and then you can decide to either focus on it during your master's degree or just as you continue to get experience. We typically work with the highway designers and just making sure that the roadways that are designed are safe and efficient, and we tend to be pretty proficient in data analysis. Our work involves a lot of analytical skills, like traffic simulation, forecasting, and all that stuff. Most people tend to think that traffic engineers are involved either at the beginning or just at the end of the project, but we are actually involved in all the different aspects. So in planning, we work with the planners to ensure that the alternatives that are being looked at have considered everyone that should be considered. We help in the determination of the analysis and then the ranking and the eventual selection. When it comes to design, we then work really closely with the highway geometric specialists to ensure that the number of lanes on the ramps or the roads are going to be able to handle future traffic forecasted. And then in terms of construction and maintenance, it's our job to ensure that when these activities are occurring, that it's happening in a safe environment and that there is minimal delays to the road users. Operations is kind of where we do quite a lot of our day-to-day work, and that's what I will talk a bit more about today. Now, for me personally, I think in the last how many years, every time I've been outside work and I go, oh, I'm a traffic engineer, the first thing everyone wants to talk about is congestion. They want to tell me about how some traffic signal in their neighborhood doesn't work or there's something wrong with it. And so I think that we can universally agree that congestion is an issue worldwide and we're all losing time and money to it. What has been the traditional approach to congestion management? It's been to provide additional capacity because it makes sense. If the thing is constrained, you add more lanes or you add more trottoirs on the road, or you just widen the road, or you go to an interchange because the traditional intersection isn't working, and interchanges do have a bit more capacity. I think we can all relate to the picture up here where it's like you're stuck in traffic and you know there's a project coming and you're super excited about it because you're like, we're finally going to get out of this congestion. And then the road gets built and it doesn't take very long and it reaches its capacity again. And you feel like you've just been kind of thrown back into the past. Universally, most transportation engineers are making the transition to the fact that we really cannot build our way out of congestion. But what we can do is to try to optimize the capacity that we have and the systems that we have to try to improve the flows on it, the safety and the reliability. I think reliability is always the big deal because it's like, you know what your daily commute is, but the time that it takes you every day varies along a really broad range. And that's what usually traffic engineers try to get into the nitty-gritty of that to figure out how that can be alleviated. This has led to the rise of the term, the transportation systems management and operations. And it's either TSM&O for short or just TISMO. And it's really just the fundamental shift to advocating for the funding of strategies that will focus on operational improvements, because these will help us to maintain, restore, and optimize the existing systems that we already have, but also contributes to the optimization of all the systems that we are planning. Some facts about TISMO are it requires you to understand what is causing your existing congestion. And I think this pretty much is just a confirmation that you need data. To be able to figure it out, you really do have to spend time studying what's out there. You need to know what's out there today, but also what you're hoping to achieve in the future. It does not in any way replace the road widenings and all the capacity projects. If anything, it just works to help those achieve a better result. It can apply in both urban and rural areas. While most of them include technology, not all of them will fall under what we call the Intelligence Transportation Systems, or ITS for short. It definitely requires the agencies or the management body to be committed to this kind of approach. And it also might require you to really spend time engaging with the public, because the public are the road users, and they tend to have insights that sometimes you might not have as a managing agency, or you simply just don't have that kind of insights that they have from using the roadways every day. And as I mentioned earlier, it strives to try to get the balance among all users, which traditionally we've sort of focused on just moving the vehicles. But there is a push now, and we can all see it, that it makes sense to be more inclusive, thinking about the non-motorized users, the motorcycles, the pedestrians, the bicycles. All these road users deserve an equal share of the road. Now, in understanding congestion, we tend to have two broad areas of congestion, which is the recurring one and the non-recurring. Recurring is pretty much what most of us have probably sat in already this morning. You know it's there. It's a pretty constant thing that shows up every day. And those we usually tend to classify as the bottlenecks where capacity has been reached, or it could be just as a product of poor signal timing or signals that aren't working. For the non-recurring, we have the unplanned events. So that could be something that comes from like a crash, or it's just bad weather that is causing traffic. For planned events, we know that they fall under the work zones. Construction is coming, you know there's going to be traffic. Or special events, there's a pretty big Black Stars game at the stadium. You can be guaranteed that traffic will occur around that area. As you can see from this graphic here, recurring congestion can take up almost 50% of the causes. Now, this graph, like this picture, attempts to kind of just give you a visual about the different factors that I just mentioned. Traditionally, this kind of holds for most areas, but you do need to look at the data for your specific location to figure out what the underlying causes of congestion are. If you look at everything that is in more or less the light orange, those are the things that fall under the non-recurring congestion. And then a lot of the things, the blue, which is primarily the bottlenecks, fall under the recurring congestion, which is typically addressed with capacity projects like road widening. So you can see here that at least 60% of the issues we have are not necessarily capacity related, but they are more of the non-recurring congestion. The caveat about bottlenecks is also the fact that if you take a step back, sometimes you can see that what might appear like a bottleneck is actually just because of drivers. Drivers get to maybe an always stop, and instead of everyone taking their time and going one per approach, everybody's trying to go at the same time, and then you have a bottleneck. Or you have a T intersection that the signal has failed, and the trotro drivers, taxis, private vehicles are all fighting for right of way. And so that then makes it appear like it's a bottleneck, but it is actually a driver behavior issue that could potentially be, corrected by TISMO. So that has led to the conclusion that at least 60% plus of our congestion issues could be targeted by adopting this TISMO approach. So based on everything I've said so far, you could see that TISMO it's pretty much just trying to combine a number of existing strategies, adding in some new ones, and trying to target these causes of congestion. So for the next few slides and the rest of the time, I will just quickly touch on a number of different strategies that I have been involved in and that we continue to explore whenever we have the opportunity. Now, the next few things I talk about are all going to be ITS. So they are the intelligence transportation solutions, where we've really tried to adopt technology in managing these systems. The first one is the variable speed limits. So this is when, instead of just having the static sign that tells you the speed limit is 30 kilometers per hour or 55 miles per hour, or whatever it is instead replaced by a dynamic panel, and that is connected to sensors that have been installed along the roadway. So the speed limits gets changed depending on the conditions. And so the drivers have been educated to know that when there's, for instance, bad weather, the speed limit is going to get lowered automatically. So you will see that the speed limit will change, and it's a warning for you to know that you should not speed, because this road is no longer at its optimal speed it was designed for. When we use this, we've noticed that it allows the speeds to be more uniform within the traffic stream, and the distances between the cars, that's the headways and the time between the cars, it's more uniform and traffic tends to flow smoother. Dynamic message signs work pretty well with the variable speed limit signs, because not everybody gets what you mean by the speed limit signs changing. So we tend to supplement that with the boards. And the boards kind of give the text breakdown of what might be happening or what might be causing all the speed changes. You can, some of the times they involve a lot of messages reminding the drivers not to text and drive, don't drink and drive, or it gives them a warning about the queues that are ahead. So you know that traffic is stopped in, let's say, 2 miles or 1 kilometer. So there's no point racing. You're going to end up coming to a standstill. Speed feedback signs also work along the same lines, but they're traditionally not on the freeways or high-speed areas. They're more in neighborhoods. Like if the neighborhood knows that this new subdivision has just been built, or this new apartment complex with a bigger footprint has been built, but people are speeding within the compound or within the area, then we would typically do a speed study and then deploy these signs, which are basically feedback signs, to the driver. It only gets activated if you're going above the speed limit. So if you're, sometimes when you're just at the speed limit or a little above, your speed will show up right under the static sign, and then the message about you're going too fast, slow down, also shows up. We've had some success with this because a lot of drivers are initially surprised to see that there's a personal message for them to slow down. What we've noticed is with time, they kind of just get used to it, and then sometimes just speed back up. So it has to work pretty well with some form of enforcement, where occasionally the police or someone shows up to actually apprehend someone that's going faster than the speed limit. Ramp metering is also a pretty innovative feature that we are using to manage freeways. As more interchanges are being built and all these limited freeway accesses or on huge arterials, it's becoming important for us to sort of manage the way that the vehicles merge. And so ramp metering is deployed on the on-ramp such that we control the way the vehicles get onto the freeway. So we allow about 1 or 2 cars per green light. So you'll see in the picture that this is like the on-ramp, and you get the light that cycles just between a green and a red. And we space it out and time it such that it can allow either 1 car or 2 cars to get through at a time. What this does is, if you look on the right side, it really controls the introduction of vehicles onto the freeway. So we don't have like 6 cars all trying to race each other to get on at the same time. And it helps to control the merging procedure on the ramp. And it optimizes the use of any acceleration lanes that have been provided. Electronic tolling is also more of an ITS, and it's for toll roads. It's, instead of having to stop at the toll booth, there's a heavy infrastructure investment. People have to get the transponders, which are devices that can be communicated with electronically. You mouse that onto your windscreen and you just go past the systems, the payment systems that are mounted overhead. And once you go through it, your tolls are deducted. So I guess in an ideal world, we'd probably have something like that in Ghana, where you either have like a Momo account or something, and when you go through it, the tolls are automatically deducted from your card. Dynamic shoulder lanes, we're also using it a lot for existing facilities and as well as proposed facilities. So the existing facilities would be something that we know is pretty constrained by right of way, but has a good width on the shoulders. We would then try to use the shoulders during the peak hours. So sometimes it will involve a heavy infrastructure investment if you want to make it more of an adaptive system. So something that will respond to the real-time traffic, and then people get told by the various messaging systems I've just mentioned that the shoulder is now open, so you could use that shoulder. It helps to improve capacity, but it does have enforcement issues, because if you only allow them to use the shoulder during certain times, then people might try to use it when you're not asking them to use it. What we also do is to think about it in terms of proposed projects. If we think that, this is a place we don't want to come back to in, let's say, 5 or 10 years, we make sure that the shoulder is wide enough to be used as a lane in the future, so that 10 years after a new project, you're not coming back to try to widen, but then you can try to deploy the shoulder lanes as some sort of interim measure until you can come back a few years time to widen. Reversible and managed lanes also follow the same idea. It uses a lot of all the systems that I just mentioned. It gets more complicated because now you're saying that I'm just going to have 2 lanes of traffic, let's say in the median of a highway, but in the morning, everybody's going to go south or in one direction. And then in the evening, because most people are returning, then everybody uses it in the opposite direction. It's a very, very expensive system because you're basically deploying all the lane controls and everything on the same system. And it takes quite a bit of education for the public to understand that in the mornings, I can only go in this direction, and then in the evenings, I can only go in the opposite direction. But it helps because it's an efficient use of space. It's only effective in an area that has a very clear directional peak hour. So for a fact in the morning, most people are going in this direction. But if your peaks are such that traffic is bad regardless, then the reversible lane doesn't necessarily help to control your congestion. Sometimes they are called managed lanes because they would be linked to real-time conditions. So we install a lot of sensors on the road, and as traffic gets really bad, we can start to charge people to use the lanes. The charging is a mechanism to help control that for that lane to also not exceed capacity. There have been equity issues where people complain about, if you charge, then it means if I have less money, I can't use the system. But it's a trade-off right now. It's almost like, how much is your time worth to you? If you want to go faster, pay a little bit, and then you get to go faster. The next few ones are less ITS and more of just day-to-day design ideas that we use. First one is the driveway access and safe spacing. This comes to play in a lot of the development projects. Whenever a new development is coming up, it is a very strict process through the permitting for us to ensure that they're not just getting a driveway access that is only like a few meters away from a signal or a few meters away from a major intersection. And we found that by controlling these driveways, we're able to have about 30% reduction in the accidents that happen, and we considerably improve the flows. What we have been doing for one of the state departments is to be like a traffic impact study peer reviewer, and they are very strict, and we go through it and ensure that you don't just get like driveways everywhere you want. If, for instance, you were putting up a new building on, let's say, High Street, we are going to ensure that you don't just put like your driveways a few meters apart. And we also ensure that you don't always have a full driveway. So when I say a full driveway, you don't get a driveway that you can make a left. You can just make a left in, left out. That all just causes a lot of traffic. If you're not going to put a signal or a very good control at that driveway, then we will limit you to being able to make just a right out, especially if it's a divided highway. And then you can also probably just make a right in. And then we'll let you find the nearest side streets to your development that will allow you to do those movements without impacting the major road. The other thing we've done quite successfully is to use the shoulder lane or the center line rumble strips. What we do is just have the milled or raised elements on the pavement, either in the middle to separate the opposing traffic or on the shoulders. And we like to call it the sweet sound of safety, because when you hit that, you will hear it. Your car vibrates and you literally hear it. So if you were sleeping, you will wake up. And we've had success because we've really been able to improve crashes in rural areas where people were like either taking long drives or couldn't see properly and were getting out of their lanes. The sign retroflectivity is exactly what it sounds like. We have a strict adherence for signs in terms of you being able to see them with just the headlights of your car. And then sometimes we also add an extra light in. The same goes with the pavement marking. We take it a step further with the little ITS element or like speed feedbacks, where we found a curve that has been having a lot of crashes. We try to deploy the same idea as the speed limit. If you approach that curve at a speed that's higher than what it's designed for, you get the message warning you and the sign starts to blink. I just mentioned the signing and marking, and that's one thing we've done pretty successfully. This was a project where we realized that there was a lot of weaving on the highway and a lot of crashes. So we took this existing sign above, which was very confusing because they didn't really understand this big arrow, and just put a wider sign that had the lane arrows placed over each lane. And what this has also led to is the team and I have helped some other state departments to develop interchange signing and marking guides when they found that there's been inconsistencies in the way they've signed their interchanges. The traffic management center is one of the best things as well, which exciting to know that, we have one in Accra and it has a planned expansion. It's basically being able to remotely manage your signals. So you can sit in your office, but know that you can see what's happening at signals along a corridor. And then you can remotely adjust the signals so that traffic is moving smoothly. That leads to just traffic signal systems. If you recall, poor signal timing was one of the main issues for congestion. And you tend to find that signals fail a lot or the timings have just not been updated. Signal timings and the systems have to be consistently looked at. And that is one thing we just do continuously. Because if you don't do that, then it's like you have a signal that isn't necessarily reflective of the conditions. So we've moved past having a signal that just has one time in the whole day. We've moved on to having adaptive systems that look at the traffic on each approach and they just give the green time that it needs. If there's no traffic on an approach, it's completely skipped because there's nothing more frustrating than sitting at an intersection and you're waiting for green, you don't get it, but the approach that has nobody there gets the green. Same idea with the pedestrian signal timing. We've moved on with always just going to, okay, let's just take the pedestrians off the road. They deserve to be at the at-grade intersection. And so we come up with different strategies. Sometimes we let the pedestrians go first before the vehicles, just so that they can also get a chance. We also have the priority and preemption, and I'm going to try to quickly wrap this up in the next 5 so that we can go on to the discussions. We also do a lot of priority and preemption. What it means is we design our traffic signals so that when a bus or let's say fire or an ambulance gets to it, they are able to send a signal to the traffic controller and it immediately gives them the green so that they can get through the intersections. Same thing with trains. When we have the at-grade intersection, we ensure that the train sends the signal before it gets to the intersection so that the arms can come down and the vehicles get stopped. So we eliminate all those cars and train crashes. When it comes to the design of intersections, we have a more rigorous approach to trying to figure out what the alternatives are. And these 2 examples are one of them where we had to think outside the box and convince the departments to try new intersections. And I think most people on the call might have heard already about the divergent diamond interchange, which flips usually when you're on this side of the road, you stay on that side of the road. But here it tries to move you onto the opposite side so that the left turns no longer have a conflict. So you move onto this side and then you're able to turn left instead of traditionally continuing this way, getting stopped here, and then you have to make this left. So for this intersection where we did that, you could see that a traditional diamond is going to have about 18 possible places where cars can crash into each other. But the DDI brings it down to 8. We worked on one of them for a state where we were able to just take an existing diamond and change it to a DDI, and the configuration was over pretty quickly. It included a lot of modeling, a lot of traffic simulations, a lot of discussions, a lot of public education, but in the end, they were able to save money by not widening the bridge. They were able to at least have about 96% cost savings, because if they tried to reconstruct, it was going to be over $150 million. The same idea with this one. The good thing about this was it was an existing intersection that was going to be changed to an interchange, but they just couldn't do the interchange because all the people in the quadrants really needed their access to the intersection. That's always been the biggest thing with an interchange. When you put it in, you cut off access to the quadrants and then have to try to design different ways to get to those accesses. There was a school, there were so many other things going on. It was a major transit route. So we ended up putting in a continuous flow intersection, which is like a DDI, but at an intersection. So it's the same idea. The left hands cross over to this side so that they can make this left, and they are now out of the conflict path of this through movement. By doing that, we garnered a lot of public support. It was very hectic because we had to do a lot of traffic modeling to get this approved. But in the end, I think it was worth it. The whole community was happy. When it comes to traffic management plans, it's also a more rigorous process for us because we have to make sure that we've analyzed all the different options that are available. We're very, very specific in what traffic management plans the contractor can deploy. And that's tied to the road user liquidated damages. So that's an extra liquidated damage in addition to the regular construction liquidated damages. But this one is tied to traffic and congestion. So when we specify in the TMP that if you close a road or if you have this active detour, the active detour can only be in place for 3 weeks and you need to be done with the job. If they don't get done within those 3 weeks, then we start to charge them a daily rate that will be deducted from their fees. It's working pretty well so far for areas where we know that we definitely want those roads open within the shortest possible time. So to be able to integrate TISMO, you really, as I said, need to have the agency decide that we're willing to think beyond just adding new lanes or adding new capacity and sort of coming together to think through different strategies, some of which I've just mentioned, to try to combat congestion. They have to set up a system where you either have like a TISMO office that's really overseeing the idea and dissemination of this process to all the different municipalities or assemblies. We've got to develop a workforce that thinks that way. If they don't think that way, they're not going to do it. This was just a page so that I guess if you do have the slides later on, it's a quick snapshot of what TISMO involves. It's a lot of existing strategies and a lot of technology that is being constantly merged together to help combat congestion. So just a quick recap, it's just shift to funding of the integrated strategies so that we can improve what we already have and what we are planning to add. It does not replace capacity projects. I can't say that more than anything. If anything, it works in tandem with it. I personally like to say that TISMO is us trying to shift our time, focus, and funds in order to achieve time, which is take care of what we already have, improve the safety of what we have, make the systems work better, and try to enhance the system capacity.
Hey guys, how's it going?
And so this is just a quick takeaway for you that it involves a lot of moving parts. You have to have data. I think Engineer Abbas already said this a few weeks ago. You need that data to be able to do the analysis. And TISMO can occur at any part of the design process: planning, design, operations, construction, maintenance. The agencies and the public have to work together. It can be used for both existing infrastructure and new projects. And together with this system, you can actually realize an optimized transport system. I know this was a quick overview. It was a lot of things. So I think what would be helpful would be if there are specific requests for us to kind of delve deeper into specific technologies, or just more ideas about traffic signal timing or traffic signal maintenance. I think we'll definitely be open to that, and then just talk through a lot more. I'm also a certified trainer for traffic simulation, traffic modeling, traffic signal timing. And so we could always organize in-person skills refreshers, or like whatever else might come up. And that's my time.